Hi everyone, this is Alex. In today's video, we are going to talk about the chain rule. This is a very important idea in differentiation because it helps us deal with functions that have one expression inside another. Before this, we learned the power rule, which works very well for simple expressions like x to the power 5 or x to the power n. But what happens when the expressions inside the power is not just x? For example, how do you differentiate something like x squared plus 3 to the power 5? That is exactly where the chain rule comes in. In this lesson, I will first explain what the chain rule really means, and then I will show you a simple box method that makes these questions much easier to solve. Let us start with the function y equals x squared plus 3 to the power 5. To understand the structure more clearly, I'm going to introduce an intermediate variable. Let u equals x squared plus 3. Then the function becomes y equals u to the power 5. Now, this is much easier to think about. Notice what is happening here. The variable y depends on u, and u depends on x. So instead of going directly from y to x, we can think about it in two steps. First, how y changes with respect to u. Then how u changes with respect to x. That is why we write dy by dx is dy by du times du over dx. This is the idea behind the chain rule. It tells us that the rate of change of y with respect to x is the product of the rate of change of y with respect to u, which is in green, and the rate of change of u with respect to x, that is in yellow. Now, let us apply that idea. Since y is u to the power 5, we get dy over du is 5 times u to the power 4. And since u is x squared plus 3, we get du over dx is 2x. So by the chain rule, dy over dx is 5u to the power 4 times 2x. Now substitute back u equals x squared plus 3. Then it will be 5 times x squared plus 3 to the power 4 times 2x. So the final answer is 10x times x squared plus 3 to the power 4. This is what the chain rule really does. We differentiate the outside function and then multiply by the derivative of the inside function. Of course, in an exam, we usually do not want to introduce u every single time. So now let us turn this idea into a faster visual shortcut. I like to think of the inside expression as a box. So if we have a box to the power of n, and its derivative is n times box to the power of n minus 1 times box prime. In words, keep the box the same, reduce the power by 1, and then multiply by the derivative of the box. So the most important question is, what should go inside the box? If you can identify the box correctly, the differentiation becomes much easier. And here's the another important point. The box must stay exactly the same until the final step. Also, this box rule is not only for positive integer powers. It also works for the negative powers and the fractional powers, as long as we write the expression in the index form first. Now, let's look at another example. Y is 2x to the power of 3 minus 7 to the power of 4. We'll use the box method again. If we compare the question with the rule, we can see that the box should contain 2x to the power of 3 minus 7. So when we differentiate 2x to the power of 3 minus 7 to the power of 4, we get 4 times box to the power of 3. And then we multiply by the box prime, which is the derivative of 2x to the power of 3 minus 7. The derivative of 2x cubed minus 7 is 6x squared. So this gives us 4 times 2x to the power of 3 minus 7 to the power of 3 times 6x squared. And therefore, the final answer is 24x squared times 2x cubed minus 7 to the power of 3. Thanks for watching, and I'll see you in the next lesson. This has been Alex.